Hi friends, say today we will be starting our second year physics in intermediate. That is, I will be starting with electromagnetic wave. See, in electromagnetic wave EMW, MSET hardly will be getting 1 to 2 marks. In MSET, hardly will be getting 1 to 2 marks. Electromagnetic wave or waves. Okay. So this is 16th chapter in second year. Out of total 16 chapter, this is the last chapter. So first of all, we have to know what is meant by EMW, electromagnetic wave. Okay. So we all know electromagnetic wave is nothing but light waves. Electromagnetic waves are nothing but light waves. So we all know sunlight. From sunlight, light is coming out, and this is electromagnetic. So what is electromagnetic generally? Let us try to understand the electromagnetic wave. Okay. So generally electromagnetic wave is in this form. See, it will be traveling. I am showing with the diagram. This is y-axis and this is z-axis. Okay. This is unit vector and this is of course x-axis. This is x-axis and this is I cap. We all know from vectors I cap, j cap and k cap, all three are perpendicular to each other. And I is along the x direction, y cap is along, j cap is along y direction and k cap is along z direction. Okay. Now, how light waves will be traveling electromagnetic waves? In the form of electric and magnetic field vectors. Okay. It will be traveling in the form of what? Electric and magnetic field. E bar and B bar. And in what fashion? See here. If you observe carefully, very important examination point of view. In the examination they are asking regularly. Okay. This is electric field vector. Okay. And if you observe carefully, see here. This is y direction and this is x direction. And now, see this one. This is the magnetic field direction. This is magnetic field direction, please. That means, see, I am hatching the portion. This is magnetic field. This is magnetic field. Okay. This is magnetic field. This is magnetic field. This all are hatched portion is magnetic field. If you observe carefully, electric field will in the y direction, magnetic field in the z direction. That means electric field is in y direction, magnetic field in z direction. That means you can find out by cross product of two vectors. J cap cross k cap is equal to I cap from vectors. So what is I cap? Along x direction. That means the wave is propagating along x direction. So in what fashion it will be traveling, you can observe me. See, this is in y direction, electric field vector, and this is magnetic field vector. So both will be traveling in this fashion. You can set a time. Same phase both. Okay, you can see both are in same phase. This is electric vector, this is magnetic vector. Both are traveling in the same phase, you can see like this. So like this it will be traveling. Okay, like this it will be traveling. Okay, this is electric vector, magnetic field vector. So this is in y direction, electric vector. This is in magnetic field in z direction. And the propagation of wave in x direction, you can observe carefully. Clear? So J cross K, where J is nothing but electric vector. This is electric vector. Okay? And this is magnetic vector. And this becomes the velocity, propagation of wave. And three of them are perpendicular to each other. E perpendicular to V, perpendicular to B. Okay? Electric vector, magnetic vector and velocity, propagation of wave. All of them are perpendicular to each other. And this question is very important in examination. Not only IPE, in NEET exam, MSET or any entrance examination it is coming. Please note down this figure. It is very important, please. Clear? Right. So finally, light waves ani enti? Ivi electromagnetic waves anamata. Ela travel avutayi? Shunyalonchi in the space, because it doesn't require any medium like sound wave. Sound wave ki medium kavali, solid, liquid, gases. Kani light electromagnetic waves ki medium avasam ledhu. It can travel even through vacuum. So in what fashion it will be traveling? In the form of electric and magnetic field vectors. And you can see in y direction electric field, and in z direction it is magnetic field, and the propagation is along the x direction. Please note down, this figure is very important for understanding purpose. Okay, right. Now let us see some equations regarding the electric and magnetic field. Okay, let us understand some equations. So what are the equations? Let us see some equations. Let us see some equations of yes friends, just a small sorry here now. So power cut is there, that's why. Okay, right, let us continue the chapter now. Now I am saying about equations of the electromagnetic wave. Okay, so let us see what are the equations of electromagnetic waves. So let us write some equations in mathematical form for the electromagnetic waves. చూడండి ఒకసారి, మీకు ముందే చెప్పాను, electromagnetic wave electric field vector ఎలా ఉంటుంది? Along y direction. Along y direction, that is j cap. Okay, the same fashion magnetic field vector ela untundi? Along z direction, that is k cap, and the propagation is how much? Along x direction. Propagation of the wave, in which direction the wave is going, that is along x direction, that is I cap. Clear? So here you can observe carefully. The equations goes like this. As we know, electromagnetic wave is traveling in the form of electric and magnetic field vectors. Okay, so you can see, just now I am telling about electric field vector ఎలా వెళ్తుంది? Y direction వెళ్తుంది. So equation ఎలా రాయొచ్చు? See, electric field vector is going in y direction. So E suffix y is equal to E0 amplitude. So like this, I'll draw here the figure. Okay, for example, this is y direction, this is z direction. Okay, okay, z direction kaadu, I'll take x this one, because I am telling about the electric vector. See, electric vector ela veltundi? Ila veltundi. Okay, this is maximum value, peak value. How much? E0. Okay, this is the displacement along x direction, displacement of the wave. So if you observe electric field vector displacement ఎటువైపు ఉంది? It is along y direction. So Ey is equal to E0 into sin kx minus omega t. Which direction it is going? Y direction. Clear? Clear all of you? So this is the equation, sign form of electric field vector. Okay, so displacement is maximum. Maximum means maximum amplitude, and this in the displacement is in a direction only, y direction only, and it is propagating in x direction. Okay, so this equation, and here you observe kx minus omega t undi, ante kx plus minus ఉన్నప్పుడు పాజిటివ్ x, రెండు ప్లస్లు ఉన్నప్పుడు నెగిటివ్ x, రెండు మైనస్ ఉంటే మైనస్ నెగిటివ్ x direction. Already I discussed in sound, but once again when I start second in sound chapter, there I will be telling again here. So ఒకటి ప్లస్ మైనస్ ఉన్నప్పుడు positive x direction. You can see direction of the wave in x direction. X direction wave. Okay. So if suppose here y is there, y direction. Z is there, z direction. So here plus or minus is there, no. So therefore the wave is going in positive x direction. If suppose both are plus, kx plus k omega t, then negative x direction. Both are minus, negative x direction. Depending upon the function here. If it is x, x direction, y, y direction, z, z direction. Clear? Now let us write the equation for magnetic field. Where magnetic field you can see it in which direction? Z direction. You can see magnetic field, this is the maximum amplitude of magnetic field, that is B0, and this is the displacement of the wave in x direction. So magnetic field in which direction? It is in z direction. So Bz is equal to B0 into sine kx minus omega t. What is the vector here? In which direction it is? Z direction. Therefore k cap. Clear? This is how you have to represent in vector form. This is how you have to represent in vector form. Clear? Okay. So here it is going in y direction, electric field vector, and magnetic field vector is going in z direction, and the displacement, the movement, the velocity is in x direction. So these are the direct diagrams and these are the equations. This is the displacement of electric vector. This is peak value, amplitude of electric vector. This is the displacement of magnetic vector in z direction, and B0 is the peak value of the magnetic vector, amplitude, and kx minus omega t kabatti plus or minus kabatti positive x direction, because x is there, x direction. If y is there, y direction. Z is there, z direction. Okay. So these are the equation k cap, because it is in displacement is in z direction. So these are the equations which are generally used in numerical problems for MSET. Okay. So this is how you have to represent the equations of electromagnetic wave. Electric and magnetic field vector. Electric and magnetic field vector. Clear? Please note down. Very, very important in the examination point of view. Very, very important in the examination point of view. Clear? I am rubbing this figure now. Here, see all of you. So just now we have discussed about electromagnetic wave. Okay, it can travel through vacuum and it is traveling in the form of electric and magnetic field vector. It is traveling in the form of electric and magnetic field vectors. Electric vector is in y direction and this is in z direction, and equations just now written y direction E0 into sine kx minus omega t j cap, displacement of the electric vector in y direction. The same way magnetic vector in z direction, peak value sine kx minus omega t into k cap. So these are mathematical equations for the displacement of the vectors, electric vector and magnetic field vector, which are generally used in numericals. Clear? Now let us go still further and we will try to learn how to represent the peak values in terms of speed of light. Okay na? Peak values in the terms of speed of light. Peak and amplitude values and okay na? We will try to write amplitude values, peak values and enti. Peak values means amplitude values of E and B, that is E0, B0. So how to represent in terms of E0, B0 with the velocity of light, that is speed of light. Okay, generally what we will do is in air by vacuum by free space, generally in air by vacuum, air gani, vacuum gani, free space gani, the speed of light is given by E0 by B0. That means ratio of amplitude of electric vector by magnetic field vector. You can observe carefully here. We know the velocity of light value 3 into 10 power 8 meter per second. C value in air or vacuum. What does it mean? That means E0 is very much greater than B0. E0 peak value electric vector value, as you can see, C times E0 is equal to C into B0. So B0 value is very less compared to electric vector. That is why maximum will be considering electric vector. Not only this one, in next topic, that is light topic, physical optics, that is wave optics. There, while studying about the electric vector, that is polarization, another thing. Polarization లోని మనం ఒక ఎలక్ట్రిక్ వెక్టర్నే తీసుకుంటాం, మ్యాగ్నెటిక్ ఫీల్డ్ వెక్టర్ తీసుకోం. అక్కడ చాలా మందికి డౌట్ వస్తుంది. ఆ పోలరైజ్డ్ లైట్లో సార్ ఎలక్ట్రిక్ వెక్టర్ తీసుకుని మ్యాగ్నెటిక్ ఎందుకు తీసుకోరు అంటే బికాస్ ఆఫ్ దిస్ రీజన్. ఓన్లీ ఎలక్ట్రిక్ వెక్టర్ మ్యాగ్నిట్యూడ్సే తీసుకుంటాం అక్కడ, మ్యాగ్నెటిక్ వెక్టర్ తీసుకోం. ఎందుకంటే electric vector is very magnitude is very much greater than B0 from this equation. Okay, that is why electric field vector peak value is considered. Okay, so this is the first formula in air or vacuum or free space. Velocity of light or speed of light is E0 by B0, where E0 is amplitude of electric vector, maximum value of electric vector. Again B0 amplitude of magnetic vector, there is a peak value. అదేవిధంగా సపోజ్ ఇన్ ఎనీ అదర్ మీడియం అంటే ఎయిర్ వాక్యూమ్ ఫ్రీ స్పేస్ ఇది ఇన్ అదే అదర్ మీడియం, దెన్ స్పీడ్ ఆఫ్ లైట్ ఇస్ టేకెన్ ఎస్ v is equal to E0 by B0. ఓకే, దిస్ v is the speed of light in any other medium. ఓకే, అంటే ఎయిర్ వాక్యూమ్ ఫ్రీ స్పేస్ కానప్పుడు యూ హ్యావ్ టు టేక్ దిస్ ఫార్ములా. v speed of the light in any other medium, E0 amplitude of the electric vector peak value, B0 peak value or amplitude of the magnetic vector. Clear? These are used in numerical problems, very very important. Please note down. Okay, so a bit. Okay, now let us go still further in this chapter. This chapter is a very small chapter but very very important in the examination point of view, even in IP also. Okay, so we have discussed so many things regarding the velocity of light, that is speed of light. Now let us go still further. Let us talk about relation for permeability, permittivity. Okay, permeability, permittivity, speed of light and refractive index, N or mu. Let us discuss about permeability, mu or mu naught. Okay, or mu r. Mu is absolute permeability of free space, relative permeability in magnetism. Okay, that is magnetic permeability. And here permittivity, epsilon, absolute medium. Alage epsilon naught, permittivity of free space. Alage one more, epsilon naught r, relative permittivity or dielectric constant K. Okay, so let us discuss all this. Alage refractive index N or mu, speed of light C in air or vacuum, and V other medium. So what are the relations involved in this one? For example, in air by vacuum or free space, the speed of light or velocity of light is given by 1 by root over mu 0 epsilon naught 0. Very very important formulas regarding examination. In air లేదా vacuum లేదా free space లో speed of light, velocity of light is given 1 by root over mu naught epsilon naught. Here mu naught అంటే ఏంటి? magnetic permeability of free space, and దాని వాల్యూ తెలుసు కదా, 4 pi into 10 power minus 7 Henry per meter value. In the same way, epsilon naught, okay, this is permeability, this is permittivity of free space, which is used in electrostatics, okay, which is used in electrostatics, that is in Coulomb's laws will be using, okay. Identity electrostatics, permittivity of free space, permittivity of free space. So generally it is used in electrostatics. And we have a formula also there, relation, that is Coulomb's log F is equal to K into Q1 Q2 by D square, and this K value you know 1 by 4 pi epsilon naught. Here you will be using that one, okay. K value is nothing but 1 by 4 pi epsilon, constant value. And epsilon naught value also, this complete K value I can take as 9 into 10 power 9 Newton meter square per Coulomb square. Are you following here? You can find 1 by 4 pi epsilon naught value enta avutundi. This 1 by 4 pi epsilon naught value is nothing but 9 into 10 power 9 Newton meter square per Coulomb square, because epsilon value enta 1 by 4 into 9 into 10 power 9, it will go to the top. So having a 1 by 4 pi epsilon naught value, I can take it as 9 into 10 power 9. So these again I will be teaching in electrostatics. So for instance, now let us learn what is mu naught and epsilon naught. This is magnetic permeable free space, this is permittivity of in electrostatics, free space. Okay? This is in air, vacuum or free space, velocity of light or speed of light. Suppose in any other medium, then the speed of light v is taken as either 1 by root mu epsilon, v is equal to 1 by root mu epsilon, where mu is absolute magnetic permeability of the medium, and this is epsilon is absolute permittivity of the medium. And this again I can take it as C by root over mu r epsilon r. Okay? This one again I can write it as C by speed of light in air or vacuum by under root mu r epsilon r. Clear? You can check also. These two are same only. These two are same. You can check now. See? I'll check it now. 1 by root over. What is mu? Mu naught. Mu r. What is epsilon? Epsilon naught r. That is equal to C by root mu r epsilon naught. Suppose if you take squaring on both sides. If you take squaring on both sides, this root will be going away. వెళ్ళిపోయినప్పుడు ఏం క్యాన్సిల్ అవుతాయి? mu r epsilon naught r epsilon cancel. ఏం మిగిలింది ఇక్కడ? What is left over? 1 by squaring చేసిన తర్వాత mu naught epsilon naught is equal to c square. From this what is c? Root over this thing. వచ్చింది అది మళ్ళీని ఇదిగోండి. What is c? Root over this thing. So this formula is also right. ఇది ఎప్పుడు వాడతారు? In any other medium other than air, vacuum or free space, speed of light is taken as 1 by under root mu epsilon లేదా equal to c by under root mu r epsilon naught r. Please note down. These are very interesting things regarding examination point of view. Okay. Now last one, let us write in terms of Ri, refractive index. Let us write in terms of refractive index, please. In terms of refractive index, ఎలా రాయొచ్చు చూద్దాం. Okay. Now we all know in light chapter, ray optics, second year, we know what is meant by Ri. Refractive index అంటే మనకు తెలుసు. What is Ri? Velocity of light in air or vacuum by another medium. Speed of light in air or vacuum by speed of light in other medium. So speed of light ఏంటి? ఇప్పుడే చెప్పాను మనం. ఏంటి speed of light? 1 by root over mu naught speed of light in air, vacuum or free space. This by what is V? 1 by root epsilon. అంటే absolute medium mu epsilon. So this I can take it as 1 by root mu naught epsilon naught, this will go to the top, into root absolute medium permeability and permittivity by 1. So this I can take it as under root mu epsilon by mu naught epsilon naught. So this again what happens? This is nothing but what? This is nothing but under root. What is mu? Mu naught mu r. What is epsilon? Epsilon naught r by mu naught epsilon naught. Mu naught epsilon naught epsilon. What is left over? Root over mu r epsilon naught r. So refractive index formula, either mu or n, can be written as root over mu r epsilon naught r. This is another important formula. Under root mu r, relative magnetic permeability into dielectric constant or relative permittivity of the medium. This is another important notation formula which are used in the numericals. Okay? Please note down, very very important in terms of refractive index. In terms of refractive index, please. Please copy it. Let us go further still. Copied all of you. Okay. Now see, these formulas are very very important. You have to use in the examination whenever asked, as and when required. Okay, na? Now after completing successfully these formulas, now I will explain most important thing, that is Maxwell's experiment. This is very very important. In electromagnetic wave, the very very important thing is Maxwell's experiment. Maxwell's experiment. ఏంటి ఈ సైంటిస్ట్ ఎప్పుడైతే వచ్చారో మొత్తం ఫిజిక్స్ సినారియోని మార్చేశారు. He has changed the entire physics scenario. That means from Maxwell's experiment, all the laws in physics, Ampere's law, Faraday's law, Gauss law in magnetism, Gauss law in electrostatics, okay, all these he has unified and named on his name as Maxwell's circuit law, లేదా Maxwell's Ampere's law, Maxwell's Gauss law, లేదా Maxwell's Faraday's law. ఇలాగ ఆయన పేరు మీద he has unified the theory. ఒకసారి చూద్దాం అదేంటే, ఒకసారి చూద్దాం. So in his experiment he has taken two circular uncharged plates. So in his experiment ఆయన ఏం చేశాడు, he has taken two uncharged plates. These two are uncharged and connected to a wire by a battery B, and of course a small tap key for the conduction of current. Okay, so Maxwell conducted experiment. ఈ ఎక్స్పెరిమెంట్ ద్వారా ఏం కనుక్కున్నాడు, ముందు వైర్ పెట్టాడు, బ్యాటరీ, ట్యాప్ కీ ఆర్ ప్లగ్ కీ, టూ అన్చార్జ్డ్ ప్లేట్స్, ఛార్జింగ్ లేవు. సో ఎప్పుడైతే when you switch on the plug or this tap key, current will be flowing in this direction. This is the direction of current. So when current is flowing positive side, electrons will be going on opposite side. We know from physics. So when current is going, what happens? This is uncharged now. Now this becomes charged. How? Electrons will be coming out from this one. Electrons will be coming out from this one. So according to chemistry, when electrons are coming means what? It is positively charged. Whenever any body is positively charged means it is having more number of electrons. So from these electrons are coming and it is giving to here. Electrons are coming, giving to this plate. This is plate 1, this is plate 2. So thereby what happens? This plate, uncharged plate, becomes charged. It becomes charged, positive. And these electrons are coming from here. That is why it is positive. And these electrons come and deposit here. So electrons are going to this plate and అర్థం ఏంటి? Negatively charged. Negatively charged అంటే ఏంటి? It is electron acceptor. This is electron donor, positively charged. It takes electrons. So this becomes negatively charged. మీకు అర్థమైంది ఇక్కడ కాన్సెప్ట్. మ్యాక్స్వెల్ ఎక్స్పెరిమెంట్లో రెండు అన్చార్జ్డ్ సర్క్యులర్ ప్లేట్స్ తీసుకొని ఈస్ కనెక్టెడ్ టు ఏ బ్యాటరీ ఫాలోడ్ బై ట్యాప్ కీ ఆర్ ప్లగ్ కీ. వెన్ ఎలక్ట్రిసిటీ ఈస్ పాస్డ్, ఎలక్ట్రాన్స్ ఆర్ కమింగ్, ఎలక్ట్రాన్స్ డైరెక్షన్ ఆపోజిట్ టు ద కరెంట్ ఉంటుంది. సో ఎలక్ట్రాన్స్ ఆర్ రిమూవ్డ్, అండ్ రిమూవ్డ్ అంటే దిస్ బికమ్స్ పాజిటివ్లీ చార్జ్, అండ్ ఎలక్ట్రాన్స్ గో హియర్, that means it becomes negatively charged. So like this continuously these plates become charged. So what does it mean? Now electric field is developed from positive to negative. Now we can see electric field is developed from positive to negative. So what he has conducted is, suppose he has taken one magnetic compass and kept here, north south. Because current is flowing, for example, if you take a small loop here, Amperian loop at distance sum. What is the Amperian loop? Integral B dot dl is equal to mu naught times I inside. So I is flowing in this one. So the compass is deflected. So current is passing here. In the same way, he kept the compass here. Here also compass is deflected because current is flowing. He kept the compass here again, Maxwell. Here also deflected. Now he has put the compass in this one. Here nothing is there. But what he found is, here also the compass was deflected. Because that's the point. When he kept the compass, here current is flowing, but here nothing is there. So here also the current was, he found that it is passing. And ఏం జరిగింది ఆయన experiment ద్వారా, magnetic compass is deflected means there is electrical flux. Whenever there is change in electrical flux, not constant current, electrical change, continuously the electric field should be supplied from here to here. Change undali, lines pass avali. Whenever there change in electrical flux, there arises a magnetic field. Okay, just like our Faraday's laws. Change in magnetic flux induce EMF. So what he told is, here displacement current was found, and he named a new point, new letter called as displacement current, and that he has indicated with letter I suffix D. What is the displacement current? When the compass he kept here deflected because current is flowing, here deflected, but here also deflected. So that means here some displacement current was there, and this current is called as conduction current IC, and this is displacement current ID. Again here from the wire, conduction current. So it is going like this. Current is passing, electrons is coming like this, current is passing like this, field is in this direction. So not only that, what he told is, conduction, whenever conduction, అంటే ఇప్పుడు ఎలక్ట్రిసిటీ ఫ్లక్స్ లైన్స్ కంటిన్యూస్గా వ్యారీ అవుతున్నప్పుడు మాత్రమే కరెంట్ ఉంటుంది అక్కడ. సపోజ్ దీస్ ప్లేట్స్ కంప్లీట్లీ ఛార్జ్డ్ అయిపోయింది అనుకోండి, సపోజ్ దీస్ ప్లేట్స్ ఆర్ కంప్లీట్లీ ఛార్జ్డ్, నౌ నో మోర్ ఫీల్డ్ ఈస్ గోయింగ్, కంప్లీట్లీ ఛార్జ్ అయిపోయి బ్యాటరీ లాగా, లేదా కంప్లీట్లీ ప్లేట్స్ మొత్తం ఛార్జ్ అయిపోయి. వెన్ ఇట్ ఈస్ కంప్లీట్లీ ఛార్జ్డ్, వాట్ హ్యాపెన్స్? No more change in field. When there is no change in field, there is no flux, there is no displacement current. Therefore, IC is equal to 0, ID is also 0. Why? Because according to Maxwell's experiment, there should be continuously change in electrical flux. Because the plates are completely charged, there is no change. When there is no change in electrical flux, no current. So IC is equal to 0, ID is equal to 0 when plates are completely charged. When it is flowing only, IC and ID will be there. Now, he has given an equation for ID, displacement. Who? Maxwell, great scientist. So ID is given by epsilon naught d phi E by dt. This is the equation given by Sir Maxwell. Displacement current is equal to epsilon naught, permittivity of free space, d phi E by dt, rate of change of electrical flux. Rate of change of electrical flux. Now, he has changed the Ampere circuit law on his name, unified. What is Ampere circuit? This is Ampere circuit law. That is integration around closed loop, B dot dl, magnetic field induction into elemental length, is equal to mu naught times I. This I is nothing but what? IC, conduction current. So I change this equation as first equation, that is integral B dot dl is equal to mu naught times this IC, sometimes it is IC, sometimes it is ID. Suppose the current is flowing here. When there is flux, ఇక్కడ IC ఉన్నప్పుడు ID ఉండదు, no ID. When here ID is there, no IC. When displacement current is there, no conduction current. When conduction current is there, no displacement current. When the plates are completely charged, IC, there is no change in flux, electrical flux. Therefore, IC is equal to 0, ID is equal to 0. So, this equation what you have written as IC plus ID. So, finally, I named the Ampere's circuit law as Maxwell's first one. I am writing here. I'll write on the top. Please note down. First one, Maxwell's Ampere's circuit law. First one. All the equations has changed and unified. First equation into the Maxwell's Ampere's circuit law. He has changed the name, and that equation goes like this: integral B dot dl is equal to mu naught times IC plus ID. Conduction current plus what is displacement current? Epsilon naught d phi E by dt. This is the entire equation he has changed. He has changed the Ampere circuit law into unified, that is Maxwell's Ampere circuit law, that is integral B dot dl is equal to mu naught times here mu naught is magnetic permeability of free space, that is 4 pi into 10 power minus 7. IC conduction current plus epsilon naught permittivity of free space into d phi by dt, that is rate of change of electrical flux. Clear? So this is the first equation he has changed. Now let us go to the next equations. Clear this experiment? Okay. Now second equation, how we have changed, we'll see. That is Gauss laws in electrostatics. He has changed the entire physics equations. Okay, that is 4 equations. Second, this is first one. Second one, Gauss laws in electrostatics. Gauss laws in electrostatics. We all know what are the Gauss laws. Integral E dot ds or dA is equal to 1 by epsilon naught times Q. That is Q inside. We all know in Gauss laws, electrostatics, electric field intensity closed circuit, closed loop, ds, small surface is equal to 1 by epsilon times Q net or Q inside. How much charge is flowing inside? In the same way, in magnetism, Gauss laws in magnetism. Gauss laws in magnetism, integral closed loop, instead of E, we will write B dot dA or ds, anything, small area, is equal to 0. Can you tell me why here 0 and why here 1 by epsilon naught? In electrostatics, we have isolated poles. Plus Q minus Q. Electric dipole will be existing. Okay? Plus Q minus Q. And the distance between them is 2a, electrical dipole moment. But in magnetism what happens? There is no monopoles existing. Ante north pole verega, south pole verega undadu. If you cut the magnet into smallest piece in the universe, that small piece still acts as a magnet as north pole and south pole separately. Antega north pole verega, south pole verega undavu. That means monopoles are not existing. That is why integration over closed loop B dot in magnetic, that means in magnetism, Gauss laws are not so familiar. Therefore, integral B dot dA is equal to 0. Okay? So this is the second one, this is the third one. Second one, integral E dot ds or dA is equal to 1 by epsilon naught times Q inside. This is named as Maxwell's Gauss laws. Maxwell's Gauss law in electrostatics. And as magnetism monopoles levu kabatti exist avu kabatti, this is not familiar, but still we'll write it. So integration over here, instead of electric field intensity, magnetic field intensity or magnetic field induction into dA or ds is equal to 0. Okay? So this is also you can call as same Maxwell's Gauss laws in magnetism. Maxwell's Gauss laws in magnetism. So first equation, Ampere circuit law has changed, Gauss law has changed, and Gauss law in magnetism change. The last equation, fourth one. Last equation, fourth one also he has changed. That is Faraday's laws. I'll write it here. Faraday's laws. Fourth one, Faraday's laws. Let us see what happened here in Faraday's law. Last one, Faraday's laws in electromagnetic induction. So according to Sir Michael Faraday, what is given? The induced EMF or current directly proportional to rate of change of magnetic flux. And అర్థం ఏంటి? The more you change the magnet, more flux is changed. And of course here minus is there, and this minus due to Lenz's law, conservation of energy. That means the induced current always opposes the change which is producing. Okay? So this is Faraday's laws actually. E proportional to minus d phi by dt, or E is equal to minus d phi by dt. This is Gauss laws, Faraday's laws. Faraday's laws in electromagnetic induction. He has changed this equation also as Maxwell's Faraday's law. So whenever there is EMF, there is a potential. Whenever there is EMF, there is a potential. What is the formula for potential? dV is equal to minus EdL or EdR or EdX. Okay? Whenever there is EMF, induced EMF, there is a potential. So what is the total potential developed? Integrated. So integral dV V is equal to minus, I'll take it outside, integral E dl. Okay? Now these two are same. So I can put it here in the place of E. Therefore, I write it here, the fourth equation, integration E dl, integral E dl, minus I'll take it as a magnitude, I'll take the magnitude. So integral dl is equal to minus d phi b by dt. This fourth equation is named as Maxwell's Faraday's law. Okay? So మొత్తానికి ఏం జరిగింది? By the entry of Sir Maxwell, scientist, with that small experiment, he has invented the displacement current, ID. Okay? And when ID is existing, when there is rate of change of electrical flux, when there is batteries complete, when the plates are completely charged, then what? There is no change in electrical flux, no ID, no IC, no conduction current, no displacement current. And he is given displacement current equation as epsilon naught into d phi E by dt, change in electrical flux. So he has changed the four equations: Ampere circuit law, Gauss law in electrostatics, Gauss law in magnetism, and finally Faraday's laws he has changed as Maxwell's Faraday's law. Okay? So finally these are the four equations we will be asking in the examination. Please make a note. These are very, very important. Maxwell's unified equations. Clear? Please note down. Now we are entering into the actual topic, that is last one of this one after completing. Please note down. Okay? Last point in EMW. Clear? Right. See, after learning about all these things, now we have some more thing to learn, that is intensity of electromagnetic wave. We have to see what is meant by intensity of EMW. Okay? Intensity. Intensity of electromagnetic wave. Intensity of electromagnetic wave, that is light waves. That means how you will define intensity. See, it is very easy one. Intensity is generally defined as energy per unit area in unit time. Intensity can be defined as energy, U stands for energy, per unit area in unit time. And what are SI units? Energy units ఏంటమ్మా? Joule by area meter square times seconds. And we all know joule per second is power, that is watts. So watt per meter square, or simply watt meter per minus 2. So the SI unit of intensity of electromagnetic wave can be written as like this: energy per unit area unit time, that is watt per meter square or watt meter power minus 2. This is the formula. Or else you can write in this fashion, I is equal to, what is energy per time? Energy per time is power. So power by area. So I can write as intensity of electromagnetic wave as P by A, power by area, or intensity into area is equal to power. Why I am telling all these formulas is, these are used in numericals, physics numericals. Okay? In MSET or NEET examination, these problems are coming nowadays. Please note down. So P is power, A is area, surface area in other words. Okay, I is intensity. Please note down the units. Okay. Now, let us go to some more points in this. Okay. After this one. రాస్తున్నారా ఇవన్నీ? రైట్. ఇప్పుడు మరికొన్ని విషయాలు నేర్చుకుందాం మనం. మరి కొంచెం ముందుకు వెళ్ళే ముందు అవేంటంటే ఎనర్జీ డెన్సిటీ. వాట్ ఈజ్ ఎనర్జీ డెన్సిటీ? ఎనర్జీ డెన్సిటీ అంటే ఏం లేదు, ఎనర్జీ పర్ యూనిట్ వాల్యూమ్. వాట్ ఈజ్ ఎనర్జీ డెన్సిటీ? ఎనర్జీ పర్ unit volume. That means energy divided by volume is called as energy density. So in the examination they are asking, what is the energy density of electric vector and what is the energy density of magnetic vector? What is the energy density? That means energy per unit volume of electric vector and also magnetic field vector. So it is simply given as like this. For electric vector, 1 by 4 epsilon naught E naught square, 1 by 4 energy density of electric vector. Energy density of electric vector is given by 1 by 4 epsilon naught E naught square, where epsilon naught you all know it is permittivity of free space, and E naught amplitude of the electric vector already I have given in the equations. This is one equation. And for energy density, that is per unit volume of magnetic field vector, both are same, but only the formula will be varying, that is B naught square by mu naught. And here we know mu naught is permeability of free space, 4.10 power minus Henry per meter. B naught meeku elaga telusu, it is the peak value, that is amplitude of the magnetic field vector. Both are almost same. So here what is the thing is, energy of, here energy of electric vector is almost equal to energy of magnetic vector. Both energies are same. So total energy total is nothing but UE plus UB. Both energies are same. So what we will take is generally total energy is equal to 2 times the energy. 2 times the energy. So that I can write as 2 into 1 by 4. 1 by 4 epsilon naught E naught square, or 2 ones are 2 twos are. So what is the total energy now? Energy density, in other words, energy per unit volume is equal to half epsilon naught E naught square. Okay? Half epsilon naught E naught square లేదా half B naught square by mu naught. ఏదైనా ఒకటే. Both the energies, these formulas why I am giving is, these are coming in the examination, please. Okay? These are coming in the examination. Please write down. Now I will convert this one in terms of intensity. Now I will convert this formula in terms of intensity, energy density. See how I will convert? Have you written all this? Now I will convert this one in terms of energy density. See here. Already what is intensity? Just now I told you. Energy per unit area in unit time. Energy per unit area in unit time. And E by T, energy per time is power. Energy by time is power. Okay. So ఈ ఫార్ములా ఎలా మారిపోతుంది ఇప్పుడు? ఇప్పుడే చెప్పాను మీకు. వాట్ ఈస్ టోటల్ ఎనర్జీ? Total energy is half into epsilon naught E naught square. Half into epsilon naught E naught square. Half into epsilon naught E naught square. Okay? This multiplied with C. Okay? if you multiply it with the C, okay, then you will get the intensity. Another formula, please. Okay, now I can get the intensity formula as, see, what is intensity? Energy per time. You can see here, this equation paina, intensity into area into time is equal to energy kada. Intensity into area into time is equal to energy. So intensity I can also write as half epsilon naught E naught square into C. Half epsilon naught E naught square. This formula is very good. It is used in numericals, please. Please note down. Okay. So intensity of electromagnetic wave I can write as in terms of energy. 1 by 2 into epsilon naught E naught square into C, where C is the velocity of light. That is speed of light. Clear? Now let us go to the next one, pointing vector. Pointing vector. What is pointing vector? Clear? Please make a note of this formula. This is important. Energy and intensity is equal to energy per unit area in unit time. That is equal to E by A into time, or I is equal to energy by time is power, that is P by A. This formula you have to make it in mind for next concept. Okay. Now here if you observe carefully, now we can define what is pointing vector. Now what is pointing vector? Pointing vector ante enti. Okay. This is also called as energy flux. This is also called as energy flux. Yes. Pointing vector ni manu energy flux ani kuda cheppochu. Yes. Okay. Now how you will define this one? How you will define this one? Okay. So this one I can write it as this flux, whatever flux is given by total energy. Total energy, that is half into epsilon naught into E naught square into speed of light. Pointing vector ni ela rayochu mathematical ga S ni electrical flux 1 by 2 half into epsilon naught into E naught square into C. Okay, that is pointing vector. Now we will see. So for example, a small light is taken, LED light. Point source of light. So when this light is emitted, what happens? It goes continuously like this, spherically. So light ela emit avutundi? It goes spherically. Suppose at some point you want the intensity at a distance some r. So just now I told you what is intensity. Energy emitting per unit area in unit time. That is nothing but P by A. I is equal to P by power by surface area. Now what is area here? Surface area. What is surface area of the sphere? 4 pi r square. 4 pi r square. So what does it mean? Intensity of electromagnetic waves inversely proportional to square of the radius for point source. Adhe linear source anukondi. Linear source me ela untadi? Linear source ante like a cylinder. In linear source what happens? What is the curved surface area of the cylinder? 2 pi r into L. So intensity is directly proportional to what? Okay na? That is inversely proportional to L. ఎందుకంటే ఈ distance area ఎంత అవుతుంది? P by area. చూడండి రాస్తాను. P by area is 2 pi r into L. Okay? Perimeter into length, curved surface area. So 2 pi r into L and intensity is inversely proportional to length. So for linear source, the intensity of electromagnetic is inversely proportional to length and inversely proportional to square of the radius for point source of light. For example, in the case of LED bulb. And the formula is I is equal to P by A. Very, very important, Andy. Please make a note because in the examination is asking regularly. Okay? Right. Now let us go to the last one. Last point. that is energy, how energy is expressed, that is momentum, etc. And with that we will be completing this chapter. Okay, let us see what is the momentum of electromagnetic wave or light waves. Now before going to momentum, we have to know what is energy. See, we all know, I will put the heading of course, momentum. See, what is momentum? Momentum P is equal to m into v. It's a vector of course, mass into velocity. Now, we all know what is energy. E is equal to h nu or h c by lambda, because what is nu? Frequency is equal to c by lambda from light, or energy is equal to hc by lambda. We know which h is Planck's constant, 6.62 10 power minus 34 joule second. C, speed of light 3 into 10 power 8 meters per second by lambda wavelength. Suppose if you put all these values, you will get energy in joules. ఏం వస్తుంది ఎనర్జీ ఇక్కడ? జౌల్స్లో వస్తుంది, కానీ ఇది వ్యాలిడ్ కాదు మనకి. ఓకే, సో వీ హ్యావ్ టు గెట్ ఇన్ ఎలక్ట్రాన్ వోల్ట్స్. సో ఎలక్ట్రాన్ వోల్ట్స్లో కావాలంటే ఇదంతా క్యాల్కులేషన్ పార్ట్ ఒకటి ఉంది మనకి. ఏంటంటే సి ఎనర్జీ in electron volts is given by a small approximation values there for MSET and NEET examination. ఇదంతా ఉపయోగించకూడదు మీరు, ఇది ఓన్లీ జౌల్స్లో అయితే ఎనర్జీ ఇలా చేయాలి. అలా కాకుండా ఎలక్ట్రాన్ వోల్ట్స్లో మనకి రిలేషన్ తెలుసు కదా. వాట్ ఈస్ W is equal to VQ? W is equal to VQ. W 1 volt into what is Q? Charge of 1 electron. అంటే W is equal to 1 eV. But what is 1 E? E and charge of electron 1.602 into 10 power minus 19 coulombs. So volt coulomb is equal to work joules. So W is equal to 1.60 10 power minus 19 joules. So 1 eV ante 1 electron volt is equal to 1.602 into 10 power minus 19 joules. So from this it is obtained as, if you want energy in electron volts, the factor is 1240 when lambda is in nanometers. ఒకవేళ వేవ్ లెంత్ నానోమీటర్స్లో ఇస్తే సింపుల్ ఫార్ములా ఎలక్ట్రాన్ వోల్ట్స్లో ఎనర్జీ 1240 బై లాంబ్డా ఇన్ నానోమీటర్స్. మరి ఒకవేళ యాంగ్స్ట్రమ్లు ఇస్తే యు నో 1 యాంగ్స్ట్రమ్ ఎంత? 10 పవర్ మైనస్ 10 మీటర్స్, బికాస్ 1 యాంగ్స్ట్రమ్ is 10 పవర్ 8 సెంటీమీటర్స్ కదా. 1 యాంగ్స్ట్రమ్ is equal to 10 పవర్ మైనస్ 8 సెంటీమీటర్స్. ఓకే, బై 100 మీటర్ అంటే 10 పవర్ మైనస్ అంటే 10 పవర్ మైనస్ 10 మీటర్స్. అప్పుడు ఎలా మారుస్తారు ఎనర్జీని? నో, ఎనర్జీ ఇన్ ఎలక్ట్రాన్ వోల్ట్ ఈజ్ ఈక్వల్ టు 12400 lambda in angstroms. Please note down these two. Again, when I will teach atoms chapter, then again I will give this formulas there. In atoms, we will be using this one. Okay, na? So this is a simple formula to calculate energy instead of joules. Joules lo kaakunda electron volts lo nanometer lo lambda is the value 1240 by lambda in nanometers. Directly can put and calculate. This is approximation value, not exact value, but these are exact in joules. Okay, and if lambda is given in angstroms, 1 angstrom is equal to 10 power minus 10 meters, 10 power minus 8 centimeters or 10 power minus 10 meters. So appudu meer em cheyali 12400 by lambda in angstroms. Okay, clear now? Now you observe carefully this formula. What happens? We will try to explain what is momentum. Okay na? Ika jaat chudandi. Momentum, and we already know from de Broglie's equation, lambda is equal to h by mv or h by p. Ante lambda is equal to Planck's constant by momentum. Clear? Now I will put this one as equation 2 and this one as equation 1. E is equal to h nu or hc by lambda. Now here energy, what happens? hc by lambda, instead of lambda I can put here h by p. P goes to the top. So E is equal to Pc or P is equal to E by C. Another formula for momentum of electromagnetic wave. Electromagnetic wave momentum formula enti? Energy by speed of light in air or vacuum. Very, very important formula. P is equal to E by C. Please note down. These will be studying now in next item, that is reflection. Okay, reflection on surfaces, and also we'll study when the surface is not reflecting also. Okay, reflection of surface and also not reflecting, and then when the surface is not undulated completely, అలాంటప్పుడు కూడా మనకి ఇది ఏమవుతుంది ఫార్ములా మనం చదవచ్చు. ప్లీజ్ నోట్ డౌన్. Clear? So now let us go to the next one. Please note down this one, this formula, that is momentum of electromagnetic wave is given by E by C, energy by speed of light. Now we'll go to the second last item which is left over, that is what called as reflection of surfaces. That means when surface is reflected, please here, suppose this is surface, what is the force exerted? What is the force exerted on the reflecting surface? What is the force exerted on the reflecting surface? And అర్థం ఏంటి? For example here, P is the momentum coming and hitting the surface. This is the surface AB, reflecting surface. Suppose after hitting, let it has gone with the momentum P. Now what is delta P? Change in momentum. Let us find change in momentum. How will you get delta P? Final minus initial. Final. అంటే వచ్చింది ఇలాగా. Please make a note. This I will take as positive. This I will take it as negative. X direction positive, minus x is negative. So final ఎంత ఇది? వచ్చి హిట్ అది. ఫైనల్ అంటే ఏంటి? దిస్ డైరెక్షన్ పాజిటివ్. P minus, okay, final initial coming in this direction, minus P. So P minus into minus plus 2P. So what is change in momentum for the reflecting surface? 2P. Now what is the force exerted? What is force? Force is given by delta P by delta T. You know from Newton's second law. Already Newton's laws I told you, force, average force is given by change in momentum by time. So here what is delta P? 2P. 2P by time, delta T. Okay. So therefore force is equal to 2 into P. What is P here in terms of energy? E by C by delta T. So this one is nothing but 2E by C delta T. Okay, 2E by C delta T. Clear? So like this you can write down the equation. Any doubt? 2E by C delta T. So this is one equation, force exerted for reflecting surfaces. Sometimes delta T is taken as small t also. Sometimes the delta T can take as small t, then this force exerted becomes 2E by Ct. 2E by Ct. Clear? Right. Now let us go for next one, non-reflecting surfaces. Okay? Let us go for non-reflecting surfaces. Clear? And we have one more equation before audition intensity enti? Power by area. Intensity is equal to power by area. Okay? So you can utilize and you can manipulate the formulas as and when required, but this formula you can remember. Thereby you can change the formula whenever it is required. Okay na? ఇప్పుడు లాస్ట్ దానికి వెళ్దామండి. Non-reflecting surface. Suppose the surface is undulated. Now what happens to the force exerted? We'll see. Okay. Now let us see the last one. Suppose the surface is in this fashion. Non-reflecting surface, PQ. And for example here, this is the momentum of the wave has come, no reflection, no reflection, that means 0. That means P is equal to 0 reflection. Now what happens to the delta? Change in momentum. Change in momentum is equal to final minus initial. So change in momentum, final enti vachi vellindi enta sunna, positive direction. So 0 minus P, that is change in momentum is equal to 0 minus into minus plus P. So what is change in momentum for non-reflecting surfaces? P. So what is force exerted? Delta P by delta T from Newton's second law, that is P by T or delta T. So force is equal to P by T. And already just now I given one equation for P also, E by C. That also you can put it here. మీకు ఇప్పుడే ఇచ్చాను ఒక ఈక్వేషన్, P is equal to E by C అని ఇందాక చేసాం కదా. ఓకే, వాట్ ఇస్ దట్ వన్? E is equal to H nu or Hc by lambda, and lambda is equal to H by mv. I have substituted here Hc by into P. So ఇక్కడ ఏమైంది? E by C is equal to P. You can even use that formula here. So here you can use that formula, average force P బదులు ఎంత అక్కడ? E by C into T. So these are the equations for reflecting and non-reflecting surfaces. And please make a note, these are very important in the examination point of view. Okay na? Ippudu last one to end of this chapter, that is electromagnetic spectrum. Hardly 10 minutes. Okay, hardly 10 minutes. Last part to end of this EMW, electromagnetic wave. Okay na? So this one you have to, because you have to mug up this one, last one, because there is no other method to learn this one. You have to mug up the values. Last one, if they ask in the examination, electromagnetic spectrum. Electromagnetic spectrum. Okay, so now I'll give you the electromagnetic waves, EMW, one side, and also the wavelength values, lambda, wavelength values, lambda. Okay, for different waves. Okay, okay, see here, 1 2 3 4 5 6 7. Okay, there are 7 electromagnetic waves starting from gamma rays. So gamma rays, these are electromagnetic waves and very dangerous. If continuously if you expose to these gamma rays that is present in sunlight, it may be lead to cancer also sometimes. Okay, so gamma rays are very dangerous. Now what is the wavelength range? You can see it is less than, in wavelength range చూడండి, less than 10 to the power of minus 3 nanometers. Please you have to remember these values. For gamma rays the value is I mean ఇదేంటిది 10 to the power of minus 3 nanometers. Okay, gamma rays are 10 to the power of minus 3 nanometers. Okay, now coming to X-rays. Coming to X-rays range ఎంత ఉంది? 10 to the power of minus 3 nm. Nano, you know what is nanometer? 1 nanometer is equal to 10 to the power of minus how much? 9 nano. Nano and then the nano means 10 to the power of minus 9 meters. Okay na? ఇవన్నీ తెలుసుకోవాలి. 1 angstrom 10 power of minus 8 centimeters or 10 power minus 10 meters, 1 angstrom. Okay, ఇవి కొంచెం వాల్యూస్ మీరు జాగ్రత్తగా గుర్తుపెట్టుకుంటే మనకి ఫ్యూచర్లో ఈజీ ఉంటుంది. నానోమీటర్, నానో 10 to the power of minus 9, 10 to the power of minus 9 meters. Okay na? Now X-rays range anta 10 power minus 3 to 1 nanometer. So electromagnetic spectrum lo ee waves gurtupettukoవాలి, examination lo adagocchu. Just watch carefully and write 1 or 2 times on paper. You will remember the values. These are the lambda values. Okay, gamma rays ki 10 power minus 3 nanometers. X-rays range 10 power minus 3 to 1 nanometer. Now UV rays, ultraviolet rays, దీని range ఎంత 1 nanometer to 400 nanometers, 400 nanometers. 1 nanometer to 400 nanometers. 1 nanometer నుంచి 400 nanometers. Now visible spectrum, that is called as Vibgyor. Violet, indigo, blue, green, yellow, orange, red. Visible spectrum ఏంటంటే 400 నుంచి 700. 400 nanometers to 700 nanometers. Next one, infrared rays. IR. Infrared. Okay? Infrared rays 700 to 1 millimeter. 700 nanometer to 1 millimeter. Microwaves. 1 millimeter to, even range and you have to remember, 1 millimeter to 0.1 meters. And last one, radio waves greater than point. This is greater, this is less than. Okay na? Okay, the greater. This symbol is greater, this is less. Greater, less. Greater than 0.1 meters. So these are the lambda values, wavelength values. For gamma rays you can see it is 10 power minus 3 nanometers. 1 nano is 10 power minus 10 meters. Angstrom 10 power minus cm or 10 power minus 10 meters. X-rays 10 power minus 3 nanometers to 1 nanometer. UV rays 1 nanometer to 400 nanometers. Okay, and finally visible spectrum Vibgyor 400 nanometers to 700 nanometers, and infrared 700 nanometers to 1 millimeter, and microwaves 1 millimeter to 0.1 meters, and finally radio waves greater than 0.1 meters. Please check the values, try to remember, because in the examination they will be coming, you have to write exactly. Okay, and I think this will be the end of this chapter, that is 16th chapter, electromagnetic wave. In MSET 1 to 2 marks only hardly, and I think NEET will be asking around 6 to 8 marks in NEET examination. Okay, again we will be meeting in the next chapter.